Welcome to our screencast today. My name is Sam and I work on the Maps API for Business support team in Mountain View. Today we're talking about how to utilize the Geocoding Web Service API with your Maps API for Business account. And specifically, we'll talk about how to properly utilize the Geocoding API and also look at what are some of the key concepts you need to be aware of when using this API. So firstly, what is geocoding? Well, geocoding is the process of converting a human readable address into a latitude-longitude coordinate. You may have seen this before when you go to maps.google.com, search for an address, and then we return a nice marker of where exactly that address is on the map. And there's also what is known as reverse geocoding. And reverse geocoding is the process of converting a lat long into a human readable address. So the Geocoding Web Service API provides an interface to perform both forward and reverse geocoding in a server-side application. So what are the common applications for this? Let's say you're building an application that takes a user's location and then returns a list of stores that are nearby. Well, you may have a large database of store addresses that you need to find the location for. You can send these addresses to Google and we'll return the lat longs for those addresses. Once you have these lat longs in your database, you can issue spatial queries against your database and return stores that are within a certain radius of a user's location. This is the backbone functionality of your typical store locator application. I'm sure many of you have seen this functionality before when you go to a company's website and do a lookup of pizza restaurants or hotels or whatever it may be, and you get a listing of results that are nearby you. It's very useful for the store owners as well as the end user because you're returning your most relevant results. Another use case is if you're an enterprise customer that's tracking a fleet of vehicles with GPS devices on board. Let's say they're taxis or service vehicles. Well, then you may have a collection of lat longs of where your cars are or have been. If you're trying to build out reports of your car locations, lat longs aren't very useful in and of themselves unless you've completely memorized the world's coordinate system. So you may want to build out reports that are a bit more human readable. Well, you can send a lat long to Google and we'll return a human readable address that's associated with that lat long. The Geocoding API can be applied to various use cases, and before you get started with using it, we strongly encourage you to first check that your use of the API adheres with our terms of service, and also check whether you can use a client-side approach instead, for example, using JavaScript. In today's demo, we'll be working within the confines of a Python script that uses the Geocoding API in a server-side manner, and we'll highlight important key concepts such as quota, error handling, and throttling. But before we start our first public service announcement, Maps API for business customers, please do not forget to sign your web service URLs. The Geocoding API is a web service, so you must sign your URLs using digital signatures. This URL signing involves using an encryption algorithm, in our case the HMAC SHA-1 encryption algorithm, along with your private crypto key and the URL that you're signing in order to generate a hash value of that URL. This hash value is your signature, and it will change if your URL changes. Your signature is not your private crypto key, so please be sure not to include the crypto key in your URLs because it won't work. And also be sure not to expose the crypto key in any public-facing source code. If you want more on URL signing, there's an entire video as well as docs that are dedicated to the subject, and those are linked below. Okay, let's get started. First, we need some data. We need some addresses to geocode. We'll pull these addresses from a CSV file, which contains store names and store addresses. We'll then use a Python script to loop through the addresses in this file and send each address to the geocoding service. On to our Python file. Right now we have a rudimentary application that uses the Geocoding API to send geocode requests to Google, and this needs a bit more work. Now don't worry if you missed something here, as we have the completed code sample that's hosted at the link below. But let's quickly cover what we have so far. First off, we have a series of modules that will help us with URL signing and a few other functions that we'll cover later. There's also several predefined constants, including a crypto key. We need this to sign our URLs. A client ID, this identifies us as a Maps API for business client. Sensor, this represents the sensor parameter in our geocode request. A path to a CSV file, this is where we fetch our addresses from. And lastly, a text file, which is where we will dump the geocode response to. And continuing on to our functions, up top here we have the calculate signature function, and this is responsible for signing our URLs. Now all the code contained in this function here is covered both in the video and the docs that I referenced earlier, and those are linked below. And way down at the bottom is our get address function. This essentially opens our CSV file, loops through the rows using a for loop to fetch each address. URL encodes each address so that it can be safely passed within a URL. Constructs our URL to be signed, You can see here it passes in the encoded address, our client ID, and the sensor parameter. Then it sends this constructed URL to our calculate signature function, which is responsible for signing URLs. And then once we get the fully signed URL, we send it on to our geocode handler function for geocoding. And lastly, and most importantly, our geocode handler function. This function will execute our geocode request to Google and parse the return JSON. You'll see it starts with a try statement, opens up our text file where we will dump the JSON, makes the geocode request using the URL open function, loads the JSON response, parses the JSON for the status that's returned by the geocoder, and then dumps the JSON response to our text file. And then following that is just a series of if-else statements. Now these simply print out the geocode status that's returned, a timestamp, and the address that was geocoded, and then maybe some other messaging that pertains to the return status. So if status is OK or 0 results, print out the status, the timestamp, and the address that we geocoded. Else if request is denied or invalid request, print out the same as above along with a message saying that the URL is malformed, and check the URL. Else if status is over query, print the same as above. Then we end with an else statement that looks for any status not defined above and prints out a message saying some unknown status encountered. And finally, we end our try statement with a few exceptions in case our application encounters an HTTP or a server error. Okay, and that's it, right? Well, let's see how things actually fare when we go ahead and run our script. Okay, not so great. You can see we are getting some overquery limit errors randomly here. So why is this happening and how can we fix it? And that brings us to our second public service announcement. Maps API for business customers are given a default web services quota of 10 queries per second. So we need to set a delay in between our requests here and also be reactive to any overquery limit errors that we may detect. Back to the Python file, we need to throttle our request. By that, we just mean that we need to set up a delay between each request. So we'll set up a constant called Geocode QPS and assign it a floating point decimal of 0.1. Now this will set a delay of 0.1 seconds between each request, which will give us at most 10 queries per second. Onto our geocode handler function. We'll skip down to where the geocode request is executed and implement a sleep function that's available via the time module. And we'll do that right before the line where the geocode request is made. Now we could just feed our geocode QPS constant to the sleep function, but suppose later down the line somewhere we want to introduce some logic that dynamically adjusts the rate at which we geocode. Let's say we want to slow it down even further if we encounter any quota errors. Well, just in case, we'll set up a local variable named delay, and its initial value will be that of our geocode QPS constant that's defined up above, and then we'll feed that delay to our sleep function. Now to be reactive, let's jump down into our if-else block of code here where our script looks for overquery limit errors. And if it does detect these, let's halt our script for a whole 2 seconds before continuing on. Okay, that should keep our QPS in line and our application playing nicely with the web services. Let's run it again and see what it looks like. Alright, that looks pretty good. We're not seeing any of those intermittent overquery limit errors that we saw before. But we're not completely out of the clear. Let's say we sustain a rate of 10 queries per second for a whole day. Well, we'll eventually encounter overquota errors. This brings us to our final public service announcement. Maps API for business customers are given a default quota of 100,000 queries per day. If we run our script at 10 queries per second for 24 hours, we'll have made 864,000 requests. And you'll find that after you've exceeded your daily limit, all of your requests will return overquery limit errors despite how much throttling you've put into your application. Now you could slow your rate of requests down such that you never exceed the daily limit, but we don't want our job to have to run all day. We want to process this as quickly as possible and move on with life. So we need a way to detect when we've hit our daily limit. We'll use a while loop for that. Now this is good because it allows us to only send geocode requests if a certain condition is met, and it also allows us to re-geocode any queries that resulted in overquota errors. Right now our script just sends a request and moves on regardless of what the result was. So let's start with a while loop that only runs its containing code if we are under a certain number of overquota errors. We'll use the variable attempts to count the overquota errors, and the while loop will check whether the number of attempts is under 3. Now if we detect a status of OK or 0 results, we'll return true here, and this will break us out of the geocode handler function, and we'll move on with fetching our next address to geocode. Similarly, if we detect request denied or invalid request, we'll also return true. There is no point resetting this request as the URL itself is malformed and needs to be fixed in some way. If we detect over query limit, we'll increment our attempts by 1. And here's where the local variable delay comes in handy. We'll increment the delay by another 0.1 seconds. Now, we're not returning true here as we want the failed request to be resent. And finally, if we encounter an unknown status, we'll increment our attempts by 1, like with quota errors, and resend the request. If we do indeed hit 3 over query limit errors, we'll exit the program and print out a message saying that we may have exceeded our daily quota. Okay, this looks pretty good, but we don't want to bring our script to a grinding halt if, say, we've hit a few quota errors here and there out of tens of thousands of requests. We only want to exit if we're confident that we've actually exceeded our daily limit. We've put plenty of throttling in place such that we shouldn't see over quota errors occurring one after the other. But if we're running into quota errors back to back, then it's a strong signal that we've drained our quota for the day. So what we'll do is only count quota errors that occur consecutively, and if we hit 3 in a row, we'll stop geocoding. To only count the consecutive errors, we will reset our attempts to 0 each time the geocode handler function is called. This way, if we encounter 3 consecutive quota errors despite having throttled our requests, we can be sure we've exhausted our quota for the day. Okay, and there you have it, a very simple yet sound application that properly uses the Geocoding API. To conclude, don't forget to sign your web service URLs, throttle your queries per second, detect errors and be reactive, and detect when you've reached your daily quota. Also, as a Maps API for business customer, you can purchase additional quota from your account manager if needed, but before doing so, you should determine if your needs are better met using a client-side approach. Feel free to further explore and run the completed sample that we have hosted for you, and that's linked below. And that's it. Hope you found this screencast useful, and thanks for watching.